Okay, in example number 2, not only are we going to follow these directions, we're also going to see why this is different than example number 1. Example number 1, remember, we actually were able to determine the area underneath the curve above the x-axis. So let's see why that's different in this example. All right, so what we're going to do first is just do what we did again from section 11.1, and that is this symbol is telling us to do something with this expression with respect to x. What it's telling us to do is integrate it. So the integral of a constant is 4x, and then the integral of just negative x is negative x, add 1 to the 1 in the exponent position. There's an understood 1 right there. So 1 plus 1 is 2. Then you divide by that 2. The difference is what's happening right now. You put parentheses around that expression, put your bar here, not the type of bar that's unfortunately, well, we can't go to these bars now because they're all closed, so that's a bummer. Anyway, this is going to be an 8, and this is going to be a negative 4. All right, there's your upper limit of integration and lower limit of integration. All right. Okay, so what do we do with this? Here's what we do with it. The first thing is to determine what f of b is equal to. All right. This is the fundamental theorem of calculus we're looking at right now. So we get, there's our b value, folks. Right here's our b value. So what is capital F of b, or of 8? It's going to be what? 4 times, yes, 8, minus what? Quantity 8 squared over 2. And then we're going to subtract whatever we get here from f of a. Again, this is your a, this is your b. All right, guys, you don't have to show what I have here in blue. You do not need to show what I have here in blue. I'm just pointing out that what we're doing is the fundamental theorem of calculus. You have to show what I have here in this, with this pen. All right, so we get what? Minus the quantity of 4 times negative 4, minus the quantity of negative 4 squared, all over 2. And now let's see if we can figure this out. So at this point, just use your calculator to compute these numerical results. I'm going to tell you, and I hope you're listening, you will have to show work on test number 4. You'll have to show me work like I'm showing you right now so that I know that you know the process to find the value of a definite integral. You cannot just use your calculator for all of these. You got to be able to show me the work. All right? So, anywho, what do we get here? 32 minus 32. So that's 0. Bring down the minus. That's negative 16. This is what? 16 over 2. So you get minus 8. And so ultimately we get 0 minus negative 16 minus 8 is negative 24. So our final answer is what? 0 minus a negative 24 is just 24. Now, we're not going to put units squared here. We're just going to put 24. All right? This is not the area that's being bound by the graph over the closed interval from negative 4 to 8. Let me show you why that's the case. So this is just a rough sketch of part of the graph of the function f. It's just a linear function 4 minus x. So it's just a graph of y equals 4 minus x, or f of x equals 4 minus x. All right, so if we only looked at this graph from negative 4 to positive 8, notice that you get 2 triangles, okay? So if you actually wanted to determine the area of the entire region that's bounded by this graph over the closed interval from negative 4 to 8, you have to be able to determine the area of this part and then add it to the area of this part. Okay, so actually, and we can just do this real quick, the area of this triangle would be equal to what? I used triangles. I used a linear function to make this easier. All right. just so you can see what I'm hopefully trying to convey to you. So the area of this triangle is just what? 1/2 base times height. So 1/2 8 times 8 would be what? 32? Okay. So the actual area here is 32 units squared for this triangle. The other triangle has an area of what? 1/2, again, base times height. These are right triangles, folks. So that's 1/2 times 4, which is 8. So the area of this triangle is 8 units squared. So the area total here, the total area that's actually being bounded by these, by this entire shaded region would be equal to what? 40 units squared, okay? We'll learn how to do this using integrals down the road in this chapter, okay? But I just wanted you to see the difference. So note that what actually happened is the area that's above the x-axis gives us a positive value because all the y's are positive. And the actual value of the integral for any region that's below the x-axis is actually going to be negative. That's because all the y values are negative. So let's make a connection here. 32 minus 8 is actually the value of our definite integral. All right, 24. Let's keep moving. All right, example number 3. We're still doing the same thing here. Still trying to evaluate the definite integral. So here's what we're going to do. First step is just to rewrite the radical x as x to the 1/2. You could have also moved the 7 from being to the right of the integral symbol into the front here. You don't have to. So anyway, with that being said, what do you get? Let's evaluate this definite integral. You get 7x to the 3/2 all over 3/2. Put your parentheses around it. Put your upper limit of integration here. Lower limit of integration down there. All right. Now, let's rewrite this because we have a fractional denominator here. When you divide by a fraction, it's the same as multiplying by its reciprocal. So this whole thing divided by 3/2 is the same as this whole thing times 2 over 3. All right, so that would give us what? 14/3 x to the 3/2. We're going to be evaluating this definite integral over the closed interval from 1 to 9. All right, so let's see how that works. First part, 14/3, plug in the upper limit always first. And then second part, plug in the lower limit always second into whatever we got for the indefinite integral, okay? Or the antiderivative. All right, so what do we get now? Now we're going to actually come up with the value of this integral. It is a definite integral because of the limits of integration existing on our integral symbol. Okay, that's what makes this different from sections 11.1 and 11.2. All right, so let's figure this out. 9 to the 3/2. Use your calculator. I believe you get 27. And then 27 times 14/3, 9 times 14, 126. Over here, this is a challenging one. 1 to the 3/2, that's just 1. 1 times 14/3 then is 14/3. So I'm using my calculator now. 126 minus 14/3 is equal to this. Please make sure you always hit Math, Enter, Enter when using your calculator to convert every result into a fraction. Don't ever round unless WebAssign tells you to round or I tell you to round. Express your result in exact value form. In this case, that would be in terms of this fraction. One other thing I do want to point out here is, let's go back to this step. If you really wanted to, you could have done this step as follows. You could have factored out the 14/3, whatever the constant is, and then just done this. You don't have to do that, but if you prefer to factor out that constant, that makes your life easier. Again, they're the same thing. All right, these two are exactly the same. So it's up to you, but just so you know, you have that option if you want.